circuit theory, that is network theory concepts. I am discussing chapter 2, that is sinusoidal steady state analysis. With respect to chapter 2, I am going to start in lecture 7. In the previous session that I discussed about what are the observations from series RL circuit, series RC circuit, and series RLC circuit for AC sinusoidal supply. Now I have to see some observations from parallel RL, parallel RC, and parallel RLC circuit. First, you have to start with a sinusoidal AC source across parallel RL circuit. Students, all of you concentrate. First, you have to draw the circuit. A sinusoidal AC source across parallel RL circuit. AC sinusoidal source across parallel RL circuit. Yes. How to draw the circuit? Let the supply voltage is V, current is I. This is RMS value of supply. This is a resistive element, and you have to draw the inductor R, L. Let the total current is I. The current through the resistor is IR. The current through the inductor is IL. Since we know this, from this total I equal to, that is IR plus IL. Then how to write IR equal to, that is the current through the resistance, V by R, that is V at angle of 0, that is V by R at angle of 0. Then what is the observation here? Is IR is in phase with voltage, the angle is 0 degrees. IR in phase with voltage. These observations are important to draw the phasor diagrams. Then how to write IL equal, this IL equal, this is the parallel circuit. The voltage across the resistor and voltage across the inductor is same because the parallel branches. Then V by, how to write a inductive reactance, that is JXL, is equal to V by XL. J, how to write this? J equal to 1 at angle of 90, but minus J equal to 1 at angle of minus 90. Shall I write like this? XL at angle of 90. Bring this angle into the numerator, that is V by XL at angle of minus 90 degrees. V by XL at angle of minus 90 degrees. That is, this IL, this is minus 90 degrees. No? Minus 90 degrees means angle is measuring clockwise. Clockwise angle is lagging. Then current lags the voltage. This IL lags the voltage by angle of 90 degrees. This is minus 90. IL lags V by angle of 90 degrees. Then you have to substitute here this I equal to, what is IR? I written V by R. What is IL? This is V by JXL. Then this I equal, take the V is common, 1 by R plus. You bring this J into the numerator, it becomes minus J, 1 by XL. Shall I write like this? I by V equal to 1 by resistance, you have to take the conductance, minus 1 by reactance. What is 1 by reactance? That is the susceptance. This is inductive susceptance. That's why I'm taking the PL. This I by V equal to G minus J PL. Shall I write like this, friends? 1 by, you bring this I into the denominator of V, that is V by is equal to G minus J PL. What is G? Where G is the conductance, that you have to take 1 by resistance. What is BL? BL is inductive susceptance. You have to take this is 1 by XL. That what is V by? This V by is Z, that is 1 by Z equal to G minus J into BL. This 1 by impedance, already given definition of impedance, admittance, susceptance, reactance, all these are already given. This 1 by impedance is taken as admittance, equal to G minus J. For series branches, we are writing generally impedance. For parallel branches, we are writing the admittance. Then Y equal to G minus J into G. Y equal to G minus J into BS. These are the observation from the circuit. Now we have to draw the phasor diagrams and what is the a power triangle, what is the impedance triangle, that is mainly your admittance triangle. Then what is the observations from that? First, I'm drawing here phasor diagrams for parallel RL circuit. Here parallel branch voltage is constant, then take the voltage is the reference. Take V is the reference. This is V. Students, what is the observation here? IR in phase with voltage. Then this I am taking IR is in phase with voltage. By knowing this information only, you have to draw this phasor. This is V. This is IR in phase with voltage. But what about IL? This IL lags the voltage by angle of 90 degrees. It's lagging. This IL lags the voltage by angle of 90 degrees. This is IR and this is IL. This angle is 90 degrees. The angle is measuring in clockwise direction. This is clockwise. Then this indicates the lagging. Then this is IR. This is IL. What is this? I equal to the vector sum of IR and IL. That is, I'm taking this IR vector. This is IL vector. This resultant is the I. This is I. Let this angle is theta. This angle is theta. Then what is the angle between IR and IL? 90 degrees. The angle between IR and IL is 90 degrees. Then you have to apply the parallelogram law. I equal to square root this IR square plus IL square. You also write plus 2 IR IL cos of angle between IR and IL. The cos of angle between IR and IL is 90 degrees. Cos 90 becomes 0. That's why no need to write that up. Only how to take I equal to square root IR square plus IL square. Just like in series RL circuit, V equal to square root VR square plus VL square. Now. That is voltage. Here the parallel circuit, this the current is divided. Then I equal to square root IR square plus IL square. You can also write like this, square on both sides. Then I square equal to IR square plus IL square. That is one observation. This is the resultant current in a RL series, in a parallel RL circuit. Then from this, you have to write the what is the cos theta. Cos theta, that is the power factor. How to define from this triangle? How to define the cos? The cos you have to take IR by I. Also write the what is the sin theta. Sin theta equal to IL by what is the tan theta steps? This tan theta equal to how take the IL by I. All these are observations from parallel RL circuit. Yes, concentrate. Any doubt? So, okay, students, understood? What is the angle between IR and IL? Angle between IR and IL is 90 degrees. Angle between IR and IL is 90 degrees. So, okay. We know that here taken admittance equal to 1 by impedance. Susceptance equal to 1 by reactance. And conductance equal to 1 by resistance. What are the units of impedance, students? Ohms. What are the units of reactance? Ohms. You know this, Z, X, R. All these units are ohms. If all these are ohms, YBG also same units. What are the units of all these? YBG, that is mho, or ohm inverse. I'll take the ohm inverse, or Siemens. That's why in impedance, reactance, resistance is same units. Then admittance is 1 by impedance, susceptance is 1 by reactance, conductance is 1 by resistance. And these three parameters also having same units, that is mho or ohm inverse or Siemens. That point you have to read. Next, you draw the admittance triangle. Here I calculated the admittance now. What is the admittance in parallel RL circuit? Y equal to G minus J into BL. This admittance is Y equal to G minus J into BL. Now here I am drawing the admittance triangle. You have to draw in the next slide. That is admittance triangle. Drawing admittance triangle. Then if you draw the admittance triangle, this Y equal to G minus J into BL. Then this is taken as a conductance. I'll take this is the conductance. And this is inductive susceptance, PL, and this is admittance. This angle is theta. Then what is y equals, friends? Y equal to square root g square plus PL square. G square plus PL square. Because the admittance y equal to g minus j into PL. If you have to calculate the magnitude of admittance, g square plus PL square. Then from this you have to define what is the cos theta. The cos theta you have to take g by y. What is sin theta, students? PL by y. What is tan theta, students? Tan theta equal to PL by g. The cos theta is g by y, and the sin theta is PL by y, and tan theta is PL by g. Tan theta is PL by g. So this admittance line. Then how to draw the power triangle? We know that how to draw the power triangle. To get the power triangle, every vector of admittance triangle multiply with v square. Concept very simple, sir. In parallel branches, voltage is constant, multiply with v square. In series, current is constant, multiply with I square. Where impedance triangle is multiplied with I square, here admittance triangle is multiplied with v square to get the power. This I am drawing the power triangle. Drawing the power. This is multiply with v square, then v square into g equal to apparent power. Sorry, v square into g equal to active power. This is the active power. This you have to multiply with v square. V square into BL equal to inductive reactive power. Then you have to multiply with v square, multiply with v square, students. That is v square into y equal to apparent power. This is the theta. Very important observation, students, that you have to concentrate. V square into g is active power. Active power units is what? V square into BL, reactive power. Inductive reactive power units is where? That is reactive volt ampere. V square into y is apparent power, that is volt amperes. Then from this you have to write what the formulas. Cos theta equal to, how to write cos theta equals to, that is cos theta equal to, that is P by S, active power by apparent power. Sin theta equal to, write sin theta equal to QL by S, QL by S. What are the tan theta, friends? Tan theta equal to, you have to write tan theta equal to QL by P, QL by P, the tan theta. Yes. Then according to parallelogram law, S equal to square root P square plus QL square. P square plus Q. That is active power square plus reactive power square. This is the power triangle for parallel RL circuit. These are the observations. Next, we have to concentrate one more circuit. A sinusoidal AC source across parallel RC circuits. The second one is sinusoidal AC source. AC source across parallel RC circuit. Parallel RC circuit. Sinusoidal AC source across parallel RC circuit. Yes. Can you draw the circuit? You have tried to analyze by your own with this knowledge. This is R and this is the C capacitance. Okay. Let the source is the RMS value of source voltage is V. The RMS value of input current is I. Clear. What the current through the resistance you have to take? This is IR. Current through the capacitance is IC. And this element is the capacitance. This voltage is the V. Now can you define what is IR, students? This IR equal to V by R. That is at angle of 0 degrees. That is in RC circuit also, always IR in phase with voltage. In phase with voltage. Then what is IC, friends? This IC equal to V by minus JXC. That is V by, how to write like this? V by, that is J into V by XC. You write J equal to 1 at angle of 90 degrees. That is 90 degrees. IC equal to V by XC, that is at angle of 90 degrees. That means what the observation here? Voltage and current. Plus 90, plus 90 means anti-clockwise angle. Anti-clockwise angle is leading. That's why IC leads V. IC leads V by angle of 90 degrees. IC leads V by angle of 90 degrees. Here. You can also write like this. V equal to this, or you can write like this now. I equal to IR plus IC. This I equal to IR plus IC. This I equal to, what is IR? V by R. What is IC? V by minus JX. And also write V by R plus J into, that is V by X. Take V is common. I equal to V into this 1 by R plus J into 1 by X. You bring this V into the denominator. I by V equal to 1 by R is conductance. 1 by X is susceptance. That is capacitive susceptance. Capacitive susceptance. Okay. Then, shall I write like this? 1 by V by I. I am bringing this I into the denominator of V. This is equal to 1 by R is conductance plus J into 1 by X is that is capacitive susceptance. What is V by Z? 1 by Z equal to G plus J into BC. What is 1 by Z, friends? Admittance. This is the admittance of parallel RC circuit. G plus J into BC. This is the admittance of parallel RC circuit. That is, in a series RL circuit, important observation. Sorry, in parallel RL circuit. In a parallel RL circuit, the susceptance is negative. Minus J into, that is imaginary part is negative. But here, the susceptance is positive. That imaginary part is positive. So Y equal to G plus J into BC. Clear? So this is the observations in RC circuit. Now with this knowledge, now you have to draw the vector diagram. Draw the vector diagram, friends. According to this, these two statements are important to draw the vector. IR is in phase with voltage, IC is leads V by angle of 90 degrees. Come on, do that. Just a minute. You please continue. Please do that. Yes, friends. Now I'm drawing the vector diagram for this case. Vector diagram. That is phasor diagrams you have to write. The phasor diagram. In a parallel connection, which is the reference, friends? Voltage. Voltage is constant. What about IR? IR is in phase with the voltage. IR is in phase with. What about IC? IR is in phase, IC is leading. Current leads the voltage by angle of 90 degrees. Then this is the resultant. This is I. Let this angle is theta. From this, how we can write according to parallelogram? This is 90 degrees. I equal to square root IR square plus IC square. I equal to square root IR square plus IC square. Can also write I square equal to, that is IR square plus IC square. IR square plus IC square. Yes. What is the cos theta from this? Cos theta equal to IR by I. What is sin theta, students? IC by I. Then what is the tan theta? Tan theta equal to, that you have to write IC by IR. Tan theta equal to IC by IR. Cos theta, sin theta, and tan theta. Writing these formulas are very easy. Yes, friends. Then what is the angle between IR and IC? The angle between IR and IC is 90 degrees. IC is a phasor diagram. Yeah, this formula is important. Before drawing power triangle. First, we have to draw the impedance, that is admittance triangle. We have to draw the admittance triangle. Then what is the admittance triangle? Admittance triangle. If you draw the admittance triangle, this is conductance G. This is VC, and this is Y. This angle is theta. Then what is Y equals, friends? G square plus BC square. Square root G square plus BC square. What is cos theta? G by Y. Cos theta is G by Y square. All right. What is sin theta? Sin theta equal to BC by Y. What is tan theta? The tan theta equal to BC by G. So this is the admittance line for series RC. Sorry, not series RC. This is parallel RC. Parallel RC circuit admittance triangle, series RC circuit impedance. Can you try for power triangle? How to get the power triangle? How to get the power triangle? That is, every vector in the admittance triangle is multiplied with V square. Multiplied with V square. Then you draw this power triangle. Power triangle. The power triangle. In a power triangle, you know this phase, you know this triangle. You have to multiply with the V square. This is V square into, this is G, no? V square into G. Right. This is V square into G. Then what about this? V square into G equal to active power. What about this one, students? V square into XC. This is equal to, this is V square into XC, no? This is equal to QC. And this resultant. What about this V square into Y square? This is active power. Sorry, this is apparent power. V square into Y is apparent power. This is reactive power. This angle is theta. Then from this, according to parallelogram law, S equal to square root. What you can write, friends? P square plus QC square. S equal to square root P square plus QC square. Clear? S equal to square root P square plus. Then you have to write what is the cos theta? P by S. What is the sin theta? QC by S. What is the tan theta? QC by P. This formulas. Because this is the power triangle. Every vector in the admittance triangle is multiplied with V square, that I am getting the power triangle for RC circuit. This is for RC circuit. How to write QC equal to V square into XC. This is the capacitive reactive power. This is the active power. This is the apparent. Okay. That is, you have to take QC equal to V square into XC. P equal to V square into G. S equal to V square into. Clear, students? It is about parallel RL circuit, parallel RC circuit. Then in this observations, the last one is parallel RLC circuit. What is the observation? Just like in series RLC circuit, whatever I explained, two cases. Here also you have to see the two cases. That is IL greater than IC, IC greater. With that, here also two cases will you have to see in the discussion. That is a sinusoidal AC source. Sinusoidal AC source. AC source across parallel RLC circuit. Across parallel RLC circuit. Parallel RLC circuit. Sinusoidal AC source across parallel RLC circuit. Students, now can you draw the parallel RLC circuit? Yes, I'm drawing the parallel RLC circuit. Is a resistance. and this is the inductance, and this is the capacitance. Capacitance. Let the supply voltage is V. This RMS value of supply voltage is V. V is the RMS supply. RLC. Let current through the resistive element is IR. Current through the inductive element is IL. Current through the capacitive element is I. Then how to write IR equals, friends? IR equal to V by R at angle of 0 degrees. IL equal to V by JXL. IL equal to V by JXL. That is V by XL at angle of minus 90. IC equal to V by JXC. IC equal to V by, this is a minus JXC, capacitive reactance. This is equal to V by XC, friends. Minus J, that is at angle of minus 90. You bring into the numerator, this is plus 90. That is, this is in phase. Vector. What about this one, friends? At angle of minus 90 degrees, now IL lags V. IC equal to V by X at angle of plus 90 degrees, now IC leads V. That is IL lags V, but IC leads V. Now, you have to draw the vector diagram, that is phasor diagrams. In two cases, IL greater than IC, the another one is IC greater than IL. IL greater than IC, the other one is IL greater than IC. Yes. First, I am defining the total impedance. You have to write, let this is I, the total current is I. Then how to write I equal to IR plus IL plus IC. Then it is not arithmetic sum, it is a vector sum. What is IR equal to V by R? What is IL equal to V by JXL? What is IC equal to V by minus JX? IC equal to V by minus JX. Take the V is common. I equal to V into 1 by R minus J by XL. That you have to simplify, that you are getting minus J. This is minus J by XL plus 1 by minus JX. But this minus J you bring into the numerator, that is plus J squares, plus J by XC. Then what is I by V equal to? 1 by R is conductance, 1 by XL is inductive susceptance, 1 by XC is capacitive susceptance. Shall I write like this? You bring this I into the denominator of V, students. That is 1 by V by is equal to G plus J into, take the J is common now. This first term I am writing, this is BC. Next I am writing this term minus B. Yeah, this is, what is V by Z? That is 1 by Z is this. G plus J into BC minus BR. What is 1 by Z, friends? That is admittance. Admittance equal to G plus J into BC minus B. BC minus B. This is the admittance calculation of parallel RLC. So G plus J into BC minus, that is BL. That is BC minus BL. Is it correct? Any doubt? That is V by R. That is V by JXL plus V by minus JXC. That is 1 by R. You bring that J into the numerator, this becomes minus J. Minus J you bring into the numerator, it becomes H. But here I have to discuss different cases. Case 1 you see. If you take IL greater than IC, I am drawing the phasor diagrams. Case 1 is IL greater than IC. IL greater than IC. Can you draw the phasor diagrams? Phasor diagrams. In parallel circuit, which is the constant? In a parallel circuit, which is the constant? Voltage. Take the voltage is the reference. This IR in phase with voltage. In phase. We know this IL lags IC leads. No? Correct? IL lags IC leads. Then IL lagging. This is IL lagging by angle of 90 degrees. But here we are assuming that IL greater than IC. IL vector is more. This is IL. IC less, you have to take the small vector. Then this is 90, this also 90. Then what is the resultant? Resultant is large vector side. This is IL minus IC. Same concept I discussed even in the series circuits also. This is the resultant. This resultant is the I square. This is the theta. Clear? Then you take any angle. Angle between IR and IC, angle between IR and IL, angle between IR and IL minus IC, angle between IC and IL. This is 90 degrees. This is also, this total is 180 degrees. Clear? Now you have to write what is I equal to square root this IR square plus IL minus IC whole square. Very important. This parallel RLC circuit for IL greater than IC. IL square. IL greater than IC, then you take IL minus IC. IC greater than IL, take IC minus IL. Easy to remember. Then what is the cos theta? Cos theta is, how you can write cos theta equal to IR by I. What is the sin theta? IL minus IC by I. What is the tan theta? Tan theta you have to write this tan theta. Tan theta is IL minus IC by IR. IL minus IC by IR. Okay, this is the phasor diagram for this case. Then try for admittance triangle. For this case, admittance triangle. In case 1, I am drawing admittance triangle. Take the case of BL greater than BC. BL greater than BC. Then you know admittance triangle. This is G. This is BL. And this is BL greater than BC. BL greater than BC means the resultant is which side? BL side. If you want to clear diagram here, I'll draw like this. This is G. And this one is BC. And this is BL. The resultant is BL minus BC. And this is theta. This is y square. Then what is y equal to? Square root G square plus BL minus BC whole square. BL minus BC whole square. Then remaining you write what is cos theta? G by y. What is sin theta? Sin theta is BL minus BC by G. Sorry, BL minus BC by y. BL minus BC by y. What is tan theta, friends? Tan theta equal to BL minus BC by G. So BL minus BC by G. That is it. How to draw the power triangle? Power triangle. Power triangle. Then let QL greater than QC. QL greater than QC. If you take QL greater than QC, then directly I'm writing, or otherwise complete diagram if you want, draw the complete diagram also. I'm drawing the complete diagram. This multiply with the V square into G. This is a V square into G. This is equal to P. And this is V square into BC. V square into BC. If you multiply with V square into BC, this is equal to QC. This is which one? V square into, that is BL. V square into BL. V square into BL. This is equal to QL. Then resultant is QL minus QC. Okay, this is the result. This is the thing. This is P, this is QL minus QC, and this is V square into Y. This is equal to S. V square into Y equal to S. Now what is S equal to? Square root P square plus QL minus QC whole square. QL minus QC. Remaining formulas you write. What is the cos theta? P by S. What is the sin theta? QL minus QC by S. QL minus QC by S. What is tan theta? Tan theta equal to constant. Tan theta equal to QL minus QC by P. This case 1. So how to do by your own case 2 that I am leaving for you. This case 2. I'm giving practice. Practice. You draw the vector diagrams, all this by your own. Just formulas only I'm giving. If IC greater than IL. Case 2 IC greater than IL. What is I equal to? Square root IR square plus IC minus IL whole square. Then if BC greater than BL, then what is Y equal to? Square root G square plus BC minus BL whole square. Third one, if this, what you take, QC greater than QL, then what is the resultant? S equals, friends, square root P square plus QC minus QL whole square. Yes, just a minute. Okay, this you have to consider. You have to practice phasor diagrams. Practice phasor diagram and admittance triangle. Power line. That I'm leaving for you. Same you can get this one. This resultant is, this is downward direction, na? You can get upward direction. BC minus BL. This is downward, na? This is upward direction. This is downward, na? This is upward. IC minus IL, you can. That's the only difference. Please try to draw by your own. That I'm leaving for you. Yeah, this is about the observations from parallel RL circuit, RC circuit, and RLC circuit. Parallel RL, RC, and RLC circuit. RLC circuit. In RLC, again, two cases. What are the observations that you have to consider? But here, very important for competitive exam point of view, this circuit is important. You have to say this one. For example, if combination of elements are given, then how to simplify? That this is the circuit. The supply voltage is V. And this is resistance. That this is R1. The inductance is, you have to take the L. Series. And this is also series. RC circuit, R2. For competitive exam point of view, this circuit is important. That is RL series, RC series. These two are parallel. How you have to analyze? That this current is I. That is, this is the case of combination of elements. For combination of elements. Then how to simplify this? There's some observations I'm giving that directly you have to remember for competitive exam. And also concentrate how I'm simplifying this type of circuit. Yes, friends. Let this current is taken as I1 and this current is I2. Let this is I. Then how you can write I equal to I1 plus I. Not only final formulas, you also concentrate how I'm simplifying. I equal to I1 plus I2. Then what is I1 you tell? This I1 equal to, this is the parallel branch voltages are equal V by R1 plus JXL. Correct? R1 plus JXL. Yeah, this impedance I am writing. That this is the impedance. This you have to take the Z1. This Z1 equal to, okay, this I am writing R1 plus JXL. This is Z2 we have to take. R2 minus JXC you have to write. Then first I am calculating I1. V by R1 plus JXL. You have to multiply and divide with complex conjugate. R1 minus JXL by R1 minus JXL. It's okay. Then I1 equal to V into R1 minus JXL by these two you have to multiply R1 plus JXL, R1 minus JXL. It's just like A plus JB into A minus JB. A plus JB into A minus JB equal to A square plus B square. Then R1 square plus XL square. Then you have to simplify this R1 by R1 square plus XL square minus JXL by R1 square plus XL square. R1 by R1 plus R1 square plus XL square minus JXL by R1 square plus XL square. Shall I write like this? What is I1 here? I1 equal to, in terms of impedance, V by Z1. You have to write I2 equal to V by Z. I taken this is Z1, this is Z. I'm replacing I1 with the V by Z1. Then V by Z1 equal to this V by Z1. I1 equal to V by Z1. That is V into, that is R1 by R1 square plus XL square minus JXL by, this I'm writing R1 square plus XL square. R1 by R1 square plus XL square. Then this V cancel. Then what is 1 by Z1? This is 1 by Z. 1 by Z1 equal to R1 by R1 square plus XL square minus J into XL by R1 square plus XL square. You have to take this is the Y1. This is Y1. Then what is Y1 equal to? Therefore, Y1 equal to R1 by R1 square plus XL square minus JXL by R1 square plus XL square. This just like Y equal to G minus JB, no? RL circuit, na? G minus JB. Y1 equal to G minus J. Correct. Then you have to take the G1 minus JBL. G1 minus J. Then what is the G1? G1 equal to R1 by R1 square plus X. That is, if this combination is given, how to calculate the conductance directly, how to calculate the susceptance directly. Very important observation. XL by R1 square plus XL square. With the G1 BL calculation. Then similarly, we have to write the I2. How to write I2 equal to V by R2 minus JX. I'm writing just a slide. Yes. Whatever the formulas I'm giving, once again, you have to practice by your own. Then you can write the formulas, every formula by your own. But don't try to by heart the every formula. You have to concentrate how you are writing the formulas. Okay. Then how to write I2 equal, students? How to write I2 equal to? I2 equal to V by R2 minus JX. Multiply and divide with complex conjugate R plus JX. Then I2 equal to V into R plus JXC by R square plus XC square. For R2 square, no? This is R2. R2. R. That is R2 square plus XC square. Now you have to simplify this. V into R2 by R2 square plus XC square plus J into XC by R2 square plus XC square. Then I2 I am writing V by Z2. V by Z2 equal to V into R2 by R2 square plus XC square. That is JXC by R2 square plus XC square. V cancel. That is 1 by Z2. 1 by Z2 equal to Y2. This is equal to G2 plus JBC is equal to R2 by R2 square plus XC square plus J into XC by R2 square plus XC square. From this, what is G2 squares? R2 by R2 square plus XC square. What is BC? XC by, how to calculate the conductance and susceptance for this case? R2 square plus XC square. So this is the calculation of G2 and the BC. Clear, friends? That you have to answer. And one more observation here. What I taken I equal to I1 plus I2. Shall I write like this? this G2 calculation and the BC calculation. But what I written I equal to I1 plus I. Shall I write this I1 plus I2? I equal to I1 plus I2. One more observation. This you have to write I1 plus I2. What is I1 students? V by that is Z1 plus V by Z2. This is also important. Take V is common. I by V equal to 1 by Z1 plus 1 by Z2. Y1 plus Y2. What is 1 by Vi? V by I. Y1 is G1 minus JBL plus Y2 is G2 minus JBC. Then G1 plus G2. Take the J is common. So G1, Y2 is which one is calculated? G2 plus JBC. Yeah. Plus J is common. Plus J is common. BC minus BL. BC minus. This is 1 by Z. Na? 1 by Z is Y. Y equal to G1 plus G2 plus J into BC minus BL. BC minus BL. Then from this, what is the Y? You can write G plus JB is equal to G1 plus G2 plus J into BC minus BL. Then from this, what is G equivalent? This is G equal to G1 plus G. That is series RL circuit and series RC circuit is connected in parallel. Then resultant, what the conductance? Directly you have to take G1 plus G. What the resultant susceptance you have to take, students? BC minus B. The resultant susceptance equal to BC minus B. So that you have to consider. Okay. Actually, this is taken as a Y equivalent. If you take this is 1 by, this is Z equivalent, this is Y equivalent, this is G equivalent, this is B equivalent, then this is G equivalent, this is the B equivalent. Okay. These are the observations that you have to concentrate. If combination of elements, series RL, parallel series RC, these two are connected in parallel. How to simplify? These are the conductance and admittance, susceptance formulas. Conductance and susceptance formulas. And this is equivalent conductance and equivalent susceptance. Okay, these are the observations. Can anybody answer this question? For the circuit shown in figure, IL and I respectively, how to find the IL and I? IL and I squares. Yes. You can simplify like this. Concentrate. Apply formula for this RL combination. Apply formula for this RL combination. Then if you apply formula for this RL combination, I'm applying the formula for this RL combination. Okay. Then 13 square equal to this total current square equal to IL square plus 5 square. Then from this, what is IL square equal to 169 minus 20. Then from this, what is IL equal to, friends? Square root 144, that equal to 12 amperes. That is IL equal to 12 amperes. Then option C is not the answer, option D is not the answer. Okay. Once IL equal to 12 amperes, what is the observation here? IL equal to 12 ampere, IC is 5, IC is 24 amperes. That is IC greater than I. Then what the resultant I equal to square root IR square plus IC minus IL wholes. But in this case, if you take IL minus IC minus, in this calculation, no problem. But in I calculation, this resultant calculation, if you are calculating IC and IL separately, then only which is greater, that is it. But here there is no problem. Because square na, minus becomes plus. IR square. IR is how much? 5 square. This formula I applied for RL circuits. I square equal to IL square plus IR square. This is for RL circuit combination. 5 square plus, what is IC, students? IC equal to 24. What is IL you calculated? IL equal to 12 ampere. That is 24 minus. That is square root 25 plus. This is how much, friends? 144. This is how much you can get 13 amperes. Then I equal to 13 amperes. I equal to, we are getting, that is 12 ampere and 13 amperes. I equal to 12 ampere and 13 ampere. That is option. But suddenly you can get one doubt here, sir. This is 13 amperes, sir. Leaving current 13 amperes, sir. This is 24 amperes, sir. 24 plus 13, 37, sir. How you take? That is wrong analysis here. Here, not only, it is not arithmetic sum, it is a vector sum. That point you have to consider. It is a vector sum, sir. It is a vector sum. Don't take directly entering currents, leaving currents. This is AC analysis. It is not arithmetic sum. It is a vector sum. And according to these formulas, this is the correct. Suddenly you can get doubt. Sir, it is a 13 amperes, sir. But it is a 13, it is 24. How it is? It is not entering current sum of the leaving current. It is not arithmetic sum. It is a vector sum. That point you have to clear. For the circuit shown in figure, if the power factor of the circuit is 0.8, the power factor of the circuit is 0.8. The value of capacitance C is, you try to calculate what is the value of the capacitance. For the circuit shown in figure, if the power factor of the circuit is 0.8, the value of the capacitance is. How to solve? Come on, do it. How we can solve this problem? Okay. Try to this combination. I apply this combination. Just now I derived some formulas. This G equivalent is. This is RL series, RC series, total combination is parallel. But here R is missing. R2 is missing. Then you take that is 0. That is it. But the fundamental formula for power factor strengths, or the fundamental formula for power factor, this is parallel combination. Parallel combination power factor equal to, instead of resistance, you take the conductance. Actually, R by Z na, in series circuit. But in parallel circuit, instead of R, you take G. Instead of Z, in parallel circuit, you take Y. G by Y. Power factor formula is G by Y. Power factor formula is G by Y. This conductance by admittance. Conductance by admittance. Then in this, you have to calculate what is Y. Y equal to G plus JB. Y equal G plus JB. This I given Y equal to G plus JB. That is G equivalent, B equivalent. You have to calculate. Then how to calculate G? This G equal to G1 plus G2. How to calculate B? B equal to BC minus BL. BC minus BL. What is the formula for G1? G1 equal to R1 by R1 square plus XL square. What is G2? G2 equal to XL by R1 square plus XL square. Correct? Sorry, not G2. G2 is R2. G2 equal to, what is G2 friends? That is R2 by R2 square plus XC square. R2 by R2 square plus XC square. But what is R2 here? R1 is 1 ohm. R2 is 0. XL equal to omega L. Omega is 1 radian per second. That is 1 ohm. You have to find C. How to write XC equal to 1 by omega C. That is omega is 1. That is 1 by C you have to substitute. X equal to 1 by C you have to substitute. Then what is the BC formula? BC equal to XC by R2 square plus XC square. What is BL formula? XL by R1 square plus XL square. Somewhat lengthy problem. Calculate all this, substitute here. Then you have to equate power factor equal to 0.8. From this, you calculate what is the capacitance that I am leaving for. If you want detailed solution, I will share the solution. But just idea I am giving. You try by your own. All the formulas you. You can get that C is nearly equal to 0.9 farad. This we can get 1 farad. Okay, I will solve, but no problem. But see that you have to. If you solve this problem, you can get idea how you are applying the different formulas. That's what I'm leaving for. Substitute here, sir. G by Y form. Y you calculate. G you calculate. V you calculate. Substitute here. Substitute here. G value substitute. Then finally you have to calculate the G you calculated na G1 plus G2. G equal G1 plus. From this power factor equal to how much? 0.8. Then XC, wherever XC is there, you substitute 1 by C. You don't know about C value, na? 1 by C you substitute. Then C is the unknown value. Then you can get the C that is nearly equal to 1 farad. We can get 1 farad. Again. Still, so many questions are there. This you have to try to solve these models of questions. All this. This also I'm leaving for homework. If time is there, I will try to solve tomorrow, and I will solve some gate questions also. These are the gate models only, but direct gate questions, some questions I will select. Then you get idea how the questions are framed. Okay, you try to solve these homework. Try this today. Maximum, I will try to solve tomorrow. Then check your answers. Check your answers. With this, parallel series combination of circuits analysis is completed. But there is one more concept in the AC analysis, that is the power calculation. With that AC analysis, fundamental AC analysis concepts will be complete. Then after that, you have to see resonance concept and the coupled circuits concept. With that, total chapter 2 will be complete. Tomorrow, if you are not solving these questions, I will give the detailed solutions. And I will solve some gate questions also. These are the gate, maximum these are the gate models on accepted. So but directly I will take some gate questions also, how the questions are framed. And after that, we'll see the power calculation concept. Then you go for the concept of resonance and the coupled circuits. Students, thank you. This is about today's session. Rohit, this you have to smart gate rankers. All are small letters. Search this in your Telegram channel. Search this one, join. This is a public channel. You have to join this. Smart gate rankers. All are small letters. Search in your Telegram channel. There you go. Okay. Thank you, students. I'm ending the session.